Shack is the pet name by which radio amateurs, popularly known as ham radio operators, call their radio room. Equipment available in the shack may vary widely among radio amateurs depending on their technical skill, interests, and possibly purchasing capacity. Yet, there are some very essential items which are used by most, while some others are optional. In a minimalist setup of a new amateur radio operator, a simple handheld radio may be all that is needed to start amateur radio operations. You can use it at home as well as on the move, though there could be security issues in tactical locations. Even low Earth orbit satellites like International Space Station can be accessed using handheld radios, making it feasible to have contacts over thousands of kilometers. When I started amateur radio operations in 1985, handheld radios were not so cheap as they are today. So I started with a self-made, popularly known as homebrew, 5-watt high frequency HF radio for transmissions and home Philips Prestige vacuum tube radio for reception. That was the common setup among newcomers in that era. The solid state VU to VW and QRP low power radio was easy to assemble and all components were available locally. But now it is easier for new hams to start off with VHF UHF handheld radios which are available at comparatively low prices. I could get one only after over a decade of amateur radio operations, and at present I have none. Now we have 19 VHF repeaters in our small state of Kerala. So it is easy to contact fairly long distances with just a simple handheld radio. We did not have the luxury of repeaters when I started off in the hobby. Even the amateur radio on International Space Station was not there. Handheld radios come with well-tuned stock antenna, which is often called a rubber ducky as it is quite flexible. It has an electrically shortened monopole antenna inside, which does not need any further adjustments. That is not the case if we use an external antenna and feed line for the handheld radio. We often use that for increasing the range of our radios. With external antenna and feed line, you can access repeaters at much longer distances. Under favorable conditions, even direct contacts at longer distances are possible without the assistance of repeaters. Repeaters are a combination of receiver and transmitter, usually located at high elevation. They receive your signals, extract audio, and transmit on a different frequency. Repeaters enable long-distance contacts on VHF-UHF bands, which are otherwise limited to short-range line-of-sight communications. Range gets extended from a few kilometers to several hundreds of kilometers by the use of repeaters. Coming back to external antenna and feed line, we need a few additional testing equipment at the time of installation and for periodic checks. If the antenna and feed line are not well matched to the output stage of the radio, typically of 50 ohms impedance, standing waves form inside the feed line. A high standing wave ratio or SWR occurs due to reflection of RF power from the antenna back to the radio instead of radiating it outside in case of mismatch. This can cause damage to the final power amplifier of the radio. High power systems can also cause damage to the feed line by heating up. Hence, you need an SWR meter to check the system while installing a new antenna and feed line. For commercial antennas which are well tuned, if a matching radio and feed line are used, it is just a formal check and SWR will be near 1:1 most of the time. But for homebrew antennas, it may not be the case unless you are very meticulous with the construction details. That is when you need to tune the antenna with the help of an SWR meter. In case of popular dipole antennas, tuning can be done by either folding back the ends little by little or lengthening if needed. This is often a cumbersome procedure as you have to bring down the antenna several times for adjustment and mount it back after that. Having pulleys installed at all the antenna supports will make the process a bit easier. Even then, you have to go outside to adjust the antenna each time and come back to the shack to check the SWR. Built-in automatic antenna tuners available in most modern radios make our life a little more simpler. If the SWR is within the tuning range of the radio, usually within 3:1, all you have to do is to press the auto tuning button on the radio and wait for it to tune. The internal antenna tuner will rattle a bit, during which high SWR may be shown in the internal SWR meter. Modern software-defined radios also have built-in protective circuits which will also automatically cut down power output in case of antenna mismatch to avoid damage to the radio. During auto tuning, the radio gives out only a small power output regardless of the regular power setting chosen. When the SWR is more than 3:1, auto tuners within the radio do not tune and one needs an external antenna tuner. External antenna tuners can be automatic or manual, both of which can be bought or homebrewed. Power rating of the antenna tuner should match the highest power rating of the radio. Otherwise, it can be damaged by excessive power outputs. During the tuning process, power output should preferably be kept low for safety of the devices. In a manual tuner, we choose the inductance and capacitance to match the impedance of the antenna feedline system to that of the radio. An automatic antenna tuner does it automatically using a microcontroller which checks multiple combinations and finds the best combination for that particular system on that frequency. Tuning will not hold for another frequency and has to be retuned if it is more than 10 kHz away from the initial frequency. If you are interested in operating CW, continuous wave or Morse code, then you will need either a straight Morse key or a keyer. A simple straight key is a device which can make and break a circuit, which in turn keys the radio in such a way that it sends out the dots and dashes in telegraphic mode. In amateur radio, we call them dit and da rather than dot and dash. An electronic keyer does the same thing in a synchronized manner so that the spaces between dit and da will be uniform. Then it will be easier to copy or understand at the receiving end. Keyers with paddles can also achieve higher speeds than straight key. An advanced option is sending with a computer keyboard using a program. Such programs can also decode a received Morse code signal. While operating CW mode, it is desirable to have good audio filters in the radio and a headphone for listening. Wire antennas are commonly used by radio amateurs. A simple wire antenna is just a random length of copper wire. But a random wire antenna will not resonate to a particular frequency and needs an antenna tuner for matching. Better choice is to have a half-wave dipole antenna which has two quarter wavelength wires to either side, mounted either horizontally or in an inverted V fashion. Inverted V antenna requires only a single high mast and two lower supports. Horizontal space needed is also lesser. More advanced users have multi-element beam antennas which have higher gain and directivity. That also necessitates the use of an antenna rotator to point the antenna in the desired direction. Others use a vertical antenna with ground radials in the way broadcast stations use an antenna tower. Some amateur radio operators have antenna towers to mount beam antennas. Beam antennas are easier to make for higher bands as the size is much smaller. A multi-element UHF beam antenna is much smaller compared to an HF antenna. If you are interested in operating digital modes like FT8 and FT4, a computer with appropriate software like WSJTX and connection to control the radio from the computer are needed. That is known as CAT, Computer Assisted Transceiver Control. Most modern software-defined radios need only a simple USB cable for CAT control. Older radios need specialized cable and hardware to enable digital modes. Modern radios like FT710 have built-in sound card which facilitates digital operations. Digital signals are usually sent as an audio tone modulating an upper sideband signal and will be heard as a whistling sound if listened directly on the speaker of the radio. Computer programs with CAT control can also be used for keeping a digital log of contacts. Many free logging softwares are available online like Log4OM. A digital multimeter is quite useful for every radio amateur, and most of them have it much before they get their amateur radio license. When I started off in electronics, I was using an analog multimeter, which is difficult to find now. If you wish to wind coils as inductors for homebrewing radios or for electrically shortened loaded coil dipole antennas, an LCR meter which can measure inductance and capacitance in addition to resistance is quite useful. Another instrument useful for tuning antennas is a nano VNA. It is a handheld device which can generate tiny signals on 101 frequency steps and send to antennas. The reflected signals give a pattern of SWR values so that the frequency with least SWR can be taken as the resonant frequency of the antenna system. If the resonant frequency is below the desired amateur radio band, the antenna has to be shortened by folding back the ends. Antenna has to be lengthened if the resonant frequency is above the particular amateur radio band. As lengthening is more difficult than shortening by folding back, we often start with a higher length than needed for the particular band during the initial construction. Multi-band antennas with elements for several bands like a fan dipole will show resonance at multiple frequencies in various amateur radio bands. Tuning such antennas for each band is a laborious process. Hence, very often, minor touching up is done using the built-in antenna tuner within the radio. Please note that though antenna tuners give good impedance matching, it will not be equivalent to a perfectly tuned resonant antenna. Yet, we are often ready for such compromises in amateur radio due to time and resource constraints. Another important component of an antenna system is a common mode choke to cut off the common mode current on the outer aspect of the coaxial shield. Coaxial shields have two radio frequency currents, one on the outer aspect and another on the inner aspect. This is in addition to the current in the central conductor. The extra current on the outer aspect of the coaxial shield is called an unbalanced current or common mode current. This can cause the feed line to radiate and cause radio frequency interference on equipment in the shack. That can be prevented by using a common mode choke. Other devices needed in the antenna system are balance and impedance transformers. Balance link between the balanced antennas like dipole antennas and unbalanced feed lines like coaxial cable. Impedance transformers are needed for antennas with high feed point impedance like an unfed half-wave dipole antenna. Ladder line is a balanced feed line which has low signal loss per length of feed line compared to coaxial cables, but they have higher characteristic impedance and need impedance transformers to match the 50 ohms output impedance of modern radios. Usual coaxial cables used in amateur radio like RG8 and RG213 have a characteristic impedance of 50 ohms. RG8 is a thinner and lighter cable, while RG213 is thicker, heavier, stiffer, and naturally more expensive cable. This is just a short list of things which I use in my shack, except the ladder line, which I plan to homebrew in near future. There are many more which you can purchase and use or homebrew on your own depending on your skill and interest.